Hi pre-calculus students, this is lesson 8 of our first module. Today you'll just need your binders open to this lesson. Our goal today is kind of three things. First of all, we're going to review our conjugate, which we introduced in lesson 7, conjugate. So we'll be able to talk about that both algebraically and geometrically. We're also going to review a new term, the modulus, which is actually very similar to something we've already seen before. We'll see that as we go forward. And then number 3, we're going to discover how to divide complex numbers. So those are our 3 big topics for today, and they'll all happen here within lesson 8. Great. So for the opening exercise for our do now, we had these 3 problems that asked us to find the multiplicative inverse using the general formula that we discovered in class last time. So the general formula was like this. It was, if we have some number a plus bi, or z, the inverse was the conjugate of a plus bi. So in this case, it would be a minus bi divided by a squared plus b squared. And that formula we derived last time. If you missed this, it was in lesson 7. So go back to our website, check out the video for lesson 7, and that'll get you up to speed on multiplicative inverse. But now that we have that general formula, lining these up is pretty easy. So looking at question A plus bi, a will be 2, b will be 3, then I just plug it into our formula. So the inverse would be 2 minus 3i all over 2 squared plus 3 squared, which is 2 minus 3i all over 4 plus 9, 2 minus 3i all over 13. So the answer to the first one, that would be our multiplicative inverse. Something to keep in mind as we go forward today, this top part, this is called the conjugate, which is just the, we get it just by taking the negative of just the imaginary part. So between these two numbers, 2 minus 3i is the conjugate of 2 plus 3i. So let's do this again. We'll go a little quicker this time. The inverse will be our conjugate. So here, our imaginary part is negative 4i, so our conjugate is going to be negative 7 plus 4i. We just change the sign of only the imaginary part, and then we still divide by a plus bi. Now notice how I chose a and b. They are both negative here on our original number. A is negative 7, b is negative 4. When I put them into the squares, however, in the parentheses here, the negatives don't really end up mattering too much. Negative 7 plus 4i, all divided by 49 plus 16. 49 plus 16. That'll just be negative 7 plus 4i, all over 65. Is that right? Yeah. Cool. So that's pretty much all we need. You can go ahead and try out this last example on your own just for extra practice. But for right now, that's just a recap of last time, how we find the multiplicative inverse, and also an introduction to the term conjugates, which I highlighted in orange again there. Those are the conjugates of our original numbers. Great. So the first thing we're going to do, we're looking at this exercises 1 through 4 here, 1 through 4. It says find the conjugate and plot the complex number and its conjugate in the complex plane. Label the conjugate with a prime symbol. So I'll do the first one as an example. Our original number is a, and it's 3 plus 4i. So if I go and I'll plot this to start. I'll go real part is 3. Remember, our horizontal axis is our real axis. So I'll go over 3. 1, 2, 3. And then I'll go up 4. and the vertical axis is our imaginary axis, so I'm going up 1, 2, 3, 4 to right there. So 3 plus 4i is right there, and it is labeled point A. Now it asks us to find the conjugate and call it A prime. So I'm going to say A prime, prime is just an apostrophe. Our new number is going to be 3 minus 4i. The conjugate just takes the sign of the imaginary part and changes it. So looking at our diagram, 3 minus 4i, 1, 2, 3, down 4i, 1, 2, 3, 4, 3 minus 4i, that would be our A prime right there. So go ahead and take a couple seconds, pause the video, calculate each of the conjugates of these next numbers, and then in the next video we'll review what happens in our graph when we take the conjugate of our points.